Hello, this is a quick overview of Autodesk Fusion 360 as of November 2020. So, Fusion 360 is one of the newest 3D modelers with enhanced features built into the system, which operates cloud server based performance, which you can use on any device. Any device could include such as iPads, small netbook tablets. You can also have small desktop computers which don't have the performance to drive some of the larger CAD packages such as SolidWorks or Inventor. This system just needs to use a small performance that can power the local software, like you can see here, and uses the cloud functions to then provide all the additional rendering, extrusion and detailed view such as generative design, CAD/CAM, simulation, or rendering packages which come as part of Fusion 360 by Autodesk. So this is the main view. On the top right hand side here we have our views. We have our home view, which is currently an isometric looking at the front, top and right plane. We could also have perspective views. We could also look at having orthofaces, as well as having our traditional orthographic. We also then switch around the planes to have front. We can have our left, our back, our right, also our top, and also our bottom. So, up the top view here is we are currently in our design tab. So we can change our workspace into any of the followings, but obviously we have design, which is where we actually do our design work, or a mechanical based design geometry. Generative design, where we can take our design and we can then use AI power, artificial intelligence, to find our most optimum design when we put some functional manufacturing requirements. Render tool, where we can turn our design and look at something pretty more rendified, which can then be outputted to documents and brochures. Animation, so we can animate sort of different views to show our user how to say assemble or construct our product. Simulation, so we can perform simulation analysis, so how a part will work or fail or buckle. Manufacture, so we can generate our manufacturing toolpaths and strategies. And then we have our drawing, so you can draw from your design or from your animation, depending on what you require. So this is just our simple drawing view. Like any sort of software, the toolbar is broken down in nice symmetric views, so you can basically choose from different options. We have solid rendering and solid design, surface rendering and surface design, sheet metal rendering and sheet metal design. And then just an additional toolbar for like make, so 3D print, outputs, add-ins, which you can go to the Autodesk add-in options. Utility, so where you basically manage materials and then compute any mathematical elements alongside. Measure, so in the inspect area, so measure, interference, draft, accessibility, section analysis, and coloring cycles. And we have our toggle and our select features with lots of different options underneath. So if we're just going to make a simple 50 by 50 cube, okay, first thing you would do is you'd have to then essentially draw a 2D sketch. We need to create our sketch boundary. So click on the sketch function. It then allows you to draw on any plane. So this is going to be our front plane here, our top plane, and our right hand side. So I'm going to draw on our front plane. I know it's our front because then it orientates it round to the front hand side. Then our toolbar along the top goes into a sketch function where we've got stuff like line, rectangles, circles, spline lines, mirror, dimensions, fillet, trim, offset, and we've got our constraints, our inspection, insert any pictures that we need to draw from, and selection tools. Also, you'll notice down the bottom we have these arrows which open up any other tools which aren't on the quick access bar. So we have like different types of curves, splines, slots, So modify, fillet, trim, extend. Constraints, different types of constraints we could use, like a curvature constraint or a midpoint. Inspect, so we've got different inspection analysis we can use on our sketch. Insert canvases or meshes or DXFs from maybe like an AutoCAD package or SVG from another 3D modeling package. And then we have obviously our selection tools and finish our sketch once we completed. So I'm just going to do a simple rectangle, base it on our datum, which is in the center. And I'm just going to type 50, tab function on the keyboard, 50, enter to confirm my sketch. And it puts up these then parallel constraints. It locks basically the bottom to the top, left to the right. So essentially, if I double click and say actually I want a 55, enter to confirm by a 55 mm square, it will then update my all 4 lines. So I finish my sketch. I'm going to tick that to finish my sketch. My sketch now sits in the bottom bar, or basically the drawing down the bottom. We go to extrude. So we can extrude it by 55 to make a square. And again, if nothing appears, you can actually nothing appears like this. You can go to the select, choose your face. You can do it one-sided. You can do it across 2 sides. So say you want a 55 by 25, for instance, add on both sides and keep that plane 25 millimeters away from this offset or 55 mil away from this offset. I can have a symmetric, so I can add 2 lots on either side as well. So again, I can have distance, I can have an all distance, you can have an object, or you can have a set distance set by yourself. So I'm going to choose 55 to make a nice square. Last one is you can join, if you had an existing extrusion, you can join it, you can cut away, you could intersect, produce a new body, or you can new component will come down in our design tree here and add additional components. You can just choose new body and accept. So this is my 50 by 50 mil cube. Down the bottom here we have orbit, which we can do free or I can constrain orbit. So basically we can click around and we spin around our product in our 3D view. If I press the home tab up in here, it will take me back to the 3D. If you have a mouse, you can zoom in by using your scroll wheel, or you can also zoom in by clicking on the zoom function and dragging the left hand click. Also you can zoom to a window as well, so you can draw a window and say I want to zoom in here, or I can zoom to a fit my current display. Then we have pan, which we can pan around in a 2D concept. And also we have look at, so say you want to look at a particular face, it will then come around and orientate those particular features. So say you want to look at this particular area here, you go to look at, and it will then drag it into view. Also on your keyboard, if you have a keyboard on a mouse rather than using a tablet or an iPad, if you hold down Shift and your middle scroll wheel, you can orbit, and if you take off Shift and just hold down the middle wheel, you have pan as well. So some shortcuts there. So all I'm going to do is put a nice simple hole through the center of my cube. So I'm going to choose the top face, I'm going to drill a hole. I'm going to say my hole is from this line, I'm going to say it's 25 or 27.5 millimeters to make it in the center. And my other reference is going to be the top line, 27.5, so it's the center of 55. Now I've accidentally pressed enter, which has not accepted this hole. If I come down, click on the hole, right click, edit the feature, I can actually edit my particular component. So I want my hole to go through the whole part, so I'm going to select the extents to all, and I can actually flip the direction if I wanted to. Hole type, so we have simple hole, countable or countersink, so I'm going to have a countersink hole. Hole tap type, so we have a simple, which is non-tapped. We have a clearance tap, an actual tapered tap, so an actual one that will take a thread. Clearance will clear off a thread, they have a taper tap, so different sort of sizes running through. So I'm going to put in a tapped hole here. It's going to go full way through my part rather than an offset. It doesn't matter with my drill point because it's going to go the whole way through. So now I need to select my sizing. So I'm going to say I'm going to have a 12mm size. It's going to be an M12 by 1.75. Class 6H right hand direction. So this has now set my components above. If I say I want to actually change this to a 14, have an M14 by 2, it then obviously will update my particular components. Or if you think about it, you can override these as well. So say just say I wanted a 20mm chamfer rather than a complete socket. Also, what I could do is actually I could then provide a clearance. So say I have a machine screw and I know it's going to be an M2 or maybe an M6, for instance. I can put that in within my sizing, but basically I've got to taper it all the way through. So tapped all the way through rather than offset. Okay, and I'm just going to simply choose my sizing. So my sizing window is just slightly below this viewpoint, but I'm just going to choose 12, which will then input here. 1.75. Okay, it's countersunk all the way through. Now the countersink does look a bit small here, so I'm going to tweak my countersink just to be a 16mm countersink, like so. Press OK to accept. And again, you get the countersink size from your screw, or you could use the toolbox, actually find or model your screw and insert that in afterwards. So the other features are, obviously, if you're doing a revolve sketch, you're doing like a revolve feature, you could actually use some of the revolve features. I'm going to actually apply a fillet here, so I'm going to say that my top view is fillet, so this edge. So these 4 lines are going to be filleted, constant radius. I'm going to say my radius is going to be 0.5 of a millimeter, just to take off the sides, like so. Also, what I could have done is actually I could have selected a face, or get through the whole entire block, and I can actually fillet those components as well. So happy with that. You can also do press pull, so I can actually pull or enlarge a based function. So if I can actually choose a size, so I can press and pull. Just get a few graphical problems there, and actually I can press and pull my edges and my radiuses if you go for more of a sort of free form kind of size and you want to manipulate surfaces rather than using set dimensions. So what I could actually now do is just sort of save my component, and remember, because this is cloud space, when you come up to use the save function, it will sit in a particular part which you can sort of save. So you've got an admin project in my case, or a default project, or I can actually put a new project in and call it test, or a new folder and actually have it within my folder. And it saves on my cloud storage. It doesn't actually save on my PC. It saves to my account on Fusion 360. So that's just a sort of a brief overview. I could actually manipulate the surfaces. So I could actually start to trim down or patch or maybe create a surface sketch. I could actually say I'm going to draw on the front again. I'm going to draw a circle, 16mm circle. I'm just going to dimension this one again in the center. And this one again, just using the dimension tab. finish my sketch. And now actually what I could do is sort of manipulate my surface. I could actually say how far is my extruded surface going to be, so I could actually say it's going to come out this way by a certain amount. And what it's done here is that I've offsetted my surface. Because it's not a surface solid, I need to now patch or stitch pieces together. So I could actually say patch this one, add in my other view, and then now it makes it a solid base structure rather than having a solid part. So that's actually using the surface tools. You can build up your component in different directions. Also, I could stitch them all together to form a block, like so, rather than having hollow components. Sheet metal works slightly differently. You can obviously change a 2D format into a bended metal press, which we'll talk about in another video. So there we go. That's just a simple way of creating a nice little cube. You could actually now say, well, I don't want my components. I can actually roll back to an external view and then save on that particular function. So that's just a quick brief overview on just how to use Fusion 360. Thanks for watching.